All right, so we're going to be talking now about addition and subtraction of scientific notation, specifically around the idea of did you actually learn how to do this yesterday? And if you did, great. Feel free to just check your answers using this video. If you did not, this is a great time for you to practice some more. So first thing I do every single time is I need to go in and see step 1, step 2, step 3. Step 1, every time, I need to check the magnitudes of these. I need to check to make sure that the magnitudes are the same. So I look at this, I have a 10 to the 4, 10 to the 5. These are not the same. As I showed you yesterday, there is an easy way to remember how to move the magnitudes, which is this. If I want to move the decimal place to the left, I add. If I want to move the decimal place to the right, I subtract. Or if I want to add, I move it left, and if I want to subtract, I move it right. However you want to remember that. So in this case, I always want to try, personally, I always want to try to make the larger magnitude smaller, deal with it, and then fix it at the end. That is a personal preference simply because I would rather deal with whole numbers rather than decimal place numbers when at all possible. You can do this the other way. It's your choice. So I have a 10 to the 4 and a 10 to the 5. I need to subtract the 10 to the 5 to make it 10 to the 4. Sorry. I need to subtract 1 from there. I come over to my guide and I see that if I need to subtract, I need to move right. So I move it right 1 place. And I get 51 times 10 to the 4 plus 3.7 times 10 to the 4. My times 10 to the 4s come down here to kind of hang out for a little bit until I'm done with the rest of this addition. I have 51 and 3.7. I need to put a placeholder in. 0 plus 7 is 7. 1 plus 3 is 4. And 5. I carry my decimal place down. And I get 54.7. However, this is ugly scientific notation. I hope you see that. So I move my decimal place back. I see that when it moves left, I add. So I add 1. And I get 5.47 times 10 to the 5th. That is my final answer. So I encourage you to pause and try this next one on your own. All right, here we go. So I see step 1, I check my magnitudes. These are not the same. I'm going to try to make the larger one small first. So in order to subtract, as I see here, I need to move to the right. So I take this 4 and I move the decimal place 1, 2 to the right, and I get 400. So 400 times 10 to the 8, because I subtracted 2 by moving that twice. Sorry, 2. And I have 7.1 times 10 to the 8. As we saw earlier, this is going to come down here and be times 10 to the 8 until I need it later. So I have 400. Let me make this a little cleaner. I have 400.0 minus 7.1. So I come in and I say, well, I can't borrow here, I can't borrow here. That becomes 3, 10. 10 becomes 9, 10. 10 becomes 9, 10. 10 minus 1 is 9. Decimal place comes down. 9 minus 7 is 2. 9 minus nothing is 9. 3 minus nothing is 3. So I get 392.9 times 10 to the 8. But again, this is bad scientific notation. I cannot have 392. That is not between 1 and 10. So I move this 1, 2 times. I get 3.929 times 10. Well, I moved it to the left, so I add 2 to the 10. So, using that, go ahead and come down. I know some of you have already done a few of these problems. They've been modified slightly. Do the independent practice. You're going to be doing this 100% silently. If you have questions, feel free to raise your hand. As you're working through this, in a little bit, we're going to come back together and work on these review problems. So now the question is, how many times larger is 3 times 10 to the 6th than 150,000? So I remember from my previous notes that they need to be in the same notation in order to compare. So I look at this, one is in scientific notation, one is in standard notation. I can't have that, I need to convert them both. Personally, I prefer scientific notation, so I'm going to convert 150,000 into scientific notation by saying 1, 2, 3, 4, 5. So I end up with 3 times 10 to the 6th, and I have 1.5 times 10 to the 5th. I then divide each piece. I'm going to actually label these in the different colors so it's easier to see. Times 10 to the 6th and times 10 to the 5. And I'm going to show you how you would go through this. First off, I need to divide 3 by 1.5. So 3 divided by 1.5, that gives me 2. There we go. 3 divided by 1.5 gives me 2. So I know that 2 is going to be involved in my answer. I then come in and I need to do 10 to the 6th divided by 10 to the 5th. So 10 to the 5th, or 6th rather, 10 to the 6th divided by 10 to the 5th means I'm just subtracting my exponent. So I get times 10. 6 minus 5 is 1. So my final answer is 3 times 10 to the 6th is 2 times 10 to the 1 times larger than 150,000. So I'm going to come in and show you this one as well, and then you're going to work on the rest of these on your own. I'm going to put both into same notation, which means that they both need to be in scientific notation. I go 1, 2, 3, 4, 5, 6, 7, and I get 4.2 times 10 to the 7, and I get 2.1 times 10 to the 4. And again, I need to keep my specific pieces together, so I do 4.2 divided by 2.1, and I find out that that is also 2. My answers are not particularly interesting. And 10 to the 7 divided by 10 to the 4 just means 10 to the 7 minus 4, and I get 10 to the 3rd. So hopefully you're finding this reasonably easy. The only difference in these ones down here is we're dealing with negative powers of 10, so just make sure that you are keeping an eye on your negative exponent rules.